To use an example of forecasting of inputs, we're going to come back to Tesla because it is a big product. It actually has 10,000 unique parts to make the Tesla Model 3. And that is actually a lot less than a traditional petrol car with an internal combustion engine. That's going to need a lot more. So as complicated as Tesla is, this is going to be even more complicated for people like Mercedes and Ford and so on. But for Tesla, given that there's so many parts, that's going to make it very important that the business forecasts correctly. And part of that is that the parts need to come in a set order. When we looked at the technology strategies for Tesla, we saw all these different technologies being used, and that's because these cars are made in a set order. So the first thing was this big coil of aluminium. That represents a car. A car is going to be made from that. Well, we need that first. So before we order any other inputs. Then we were making the panels, so we need to make sure we've got all the things to store the panels as well. So if you did watch the little documentary, you'll see there's little sort of trolleys where you put on the doors and trolleys for the panels and so on. We then had this chassis being assembled, so we need to make sure we've got everything we need for parts-wise there. And maybe at this point we haven't actually ordered any of the seats or the actual engine part or anything like that because we haven't put that in yet. So that might be the next thing. We need to start ordering the paint, for example, because we're going to do that next. And then the next thing, we're going to move the car around the factory so we can put in the seats. And then really the last thing we saw was putting on the screens, and that makes sense because if we go back a step, a robot puts the seats in, well, a robot can't get into the car if the windshields and windows are in. So that makes sense. So we've got an ordering of inputs here for Tesla. So we now know what order we need the inputs. Now we've got to figure out how many we need. And one of the things that's going to help Tesla there is that we saw with technology strategies that customers actually pre-order a Tesla. It's unlike other car brands. And that's going to give them an advantage because customers jump online and you pick which model you want. That's going to affect the parts that are in it, particularly the battery, because you can see they've got a long range and an even longer range performance battery. But then the colors, so that's going to affect the paint. What type of wheels. You also got to design your interior, color scheme, and also different features. Well, now, once the customers lock that in, we can now predict, or with a pretty high degree of accuracy, what parts we're going to need. And there, how does Tesla then prepare a forecast? Well, I guess it's all asking about, well, what inputs do we need today? That's not really the question we're forecasting. Today should have already been planned for. We're saying, what inputs do we need, say, for the next 6 months? So this is today, this is next month, the month after, etc. And to do that, we're going to do a forecast. And a forecast was analyzing past data. What did we need in the past? Well, let's look at the last 12 months. So we'll start at a year ago would be negative 12 months, 11 months ago, 10 months ago, etc. And we'll just say with the Model 3, I'm just making up some numbers, but there were 50,000 orders a year ago. And then in the 11th month, 11 months ago, there were 45,000, then 60,000, etc. So now we've got that data, we're going to have a pretty good idea based on the fact that the upcoming month would have been the 12 months ago. There were 50,000 ordered a year ago. So we can start to forecast and go, well, we're probably going to have around 50,000 Model 3s this year. But a forecast is better than that. It doesn't just look at past data, it also looks at future data or predictions. So I guess now, if we're just going to go back and go, well, a year ago there was 50,000, then this month there was 45, and this month there was 60, and this month there was 40, and then 50 and 50. So we've got a little bit of a forecast now. But then we add in predictions of the future. So Tesla is very lucky here because they're going to have a lot of pre-orders that have been made. So we can lock those in. But then they can also do some market research and figure out, will the Model 3 have the same customer demand as the past? And maybe their prediction models say, we predict an extra 5,000 models will be sold each month this year. So now we can increase, this is the old data, 50,000, then 45, then 60, etc. Well, let's increase those by 5,000. And now we've got a little bit of a model for the future. And it's not 100% accurate, but it is a really good guide of what we think is going to happen. And the good thing with forecasting is we now turn that into kind of a list of parts that we need. So here's our forecast for the next 6 months of what we're going to need. We can now break down a Model 3 and say, well, every car is going to need 1 engine, 2 windscreens, 4 doors, 4 seats, and all the other parts. I'm just going to use these parts to keep the example simple. And now we've got our forecast here. We think in a month's time we're going to produce 55,000 of these. Well, we now know that means 55,000 engines are going to be needed, 110,000 screens, because there's 2 in each car. There's 4 doors, so that's 220,000 doors and 220,000 seats. And we can organize to get those parts on stock on hand now and put them in inventory. Then we can even look ahead and start to break each of these months down and know, well, roughly how many parts are we going to need, and make sure we've got them in inventory so we can put them into our operation system to make the product.